Creamer Media's Mining Weekly is interviewing Adrian Singh, the CEO of GoldOre. He is the developer of the proudly South African MAC reactor, which can assist mining companies to meet their decarbonisation obligations. Hi, Adrian. It's great to chat to you. So GoldOre, it's a company name that crosses our paths regularly these days. But what needs to cross our minds when we see GoldOre in future? Help us out, Adrian. Give us an introduction to GoldOre, the company that you've created from scratch.
Yes. So you're quite right. Rightfully hit the nail on the head with your introduction there. So GoldOre is a company that was created from scratch, and I came out of corporate. I sort of learned about metallurgy and mining, and cut my teeth with Anglo American many years ago. So I was in corporate, and then decided I needed to be on my own and do something on my own. And then, about 13 years ago now, I decided to start the company, GoldOre, and it was started to be the vehicle to market my worldwide patented Mach reactor technology, which is a technology that I'm also the inventor of. And that was a 7-year journey, and it's probably a whole other interview. We can talk about the patenting process and the pros and cons and pitfalls and joys, But anyway, we've got it through worldwide patenting, and the Mach reactor is something that I designed to be used in the metallurgical industry to assist companies with their flotation and leaching processes. And it's a very left of field design. We utilize the principle of cavitation to generate very fine picobubbles, which enhances both flotation recoveries and grades, and also enhances leach kinetics, etc., in gold plants. I suppose to sum it all up, the GoldOre with the Mach reactor technology that we market, that goes straight down to improving the bottom line for companies, not just gold and PGM, also industrial minerals, and to ensure that we stay relevant these days, also battery minerals like copper, for example. Yes.
The Mach reactor has been termed revolutionary. Why revolutionary, and what sets it apart from the competition?
I think let's talk about what the Mach reactor does, or what type of equipment it is, because for people who are not familiar, it may sound a little bit alien. But it is actually, when it comes down to it, it's actually an oxygenation reactor. So it's a device you use to put a gas into pulp. For gold leaching, for example, oxygen is used, oxygen and cyanide, to leach the gold. But it's a big challenge to get that oxygen to dissolve in the pulp, because it wants to sit above the tank and it doesn't want to be in the pulp. That's its natural habitat, is in the atmosphere. And so the question arises then is, how do you get the efficiency up? How do you manage to dose oxygen into pulp with high levels of efficiency? And the key to that, and this is widely known by everybody, the key to that is to achieve as fine a bubble as you possibly can. And all of the competition out there will produce bubbles in the centimeter size range, maybe millimeter size range. And when I developed the Mach reactor, I thought there has to be a better way. There has to be a way that I can get bubbles that are invisible, that you can't, they're so small that you can't even see. And that's the picobubble that I talk about, pico, nano, or micro bubbles. Those very fine bubbles are actually invisible. And that's what we generate in the Mach. And we ventilate those very fine bubbles with the oxygen and disperse that in the pulp. And hence we get these extremely high gas utilization efficiencies with the Mach. And we're doing that through this process of cavitation. And we're the only reactor on the market that actually uses cavitation as the basis of its design. All the rest of them are static mixers or sparges. And it's revolutionary because nobody would have thought of that. Cavitation is something that engineers run away from, because that causes destruction. That holds pipelines, it breaks pumps. Nobody wants cavitation, but we've purposefully sort of harnessed that energy in the Mach in a way that doesn't destroy the reactor. It's not destructive, but we're using that energy for, sort of to achieve our own goals, for metallurgical benefits. And that is sort of the paradox of it all. And it has cavitation in there, but it's been used for for positive gain in the metallurgical industry. And then the other side of that coin, because I've said cavitation is so powerful as a force, as an energy, we've also managed to develop a reactor that does not wear. So we have reactors out there that are running well over 10 years, and it's the same reactor. We haven't replaced any wear components, none of the internals, and they need zero maintenance. So they don't block, they don't break. And that's also revolutionary, because any other reactor of this sort, or in this category in the market, will need a replacement. A couple of months, maybe a year down the line, you would need to put in a brand new reactor. And the industry is sort of used to this. They're used to it being a high maintenance item. And here we have something that's sitting at the pinnacle of efficiency, utilizing the greatest power you can find, and it doesn't break. So I guess that's pretty revolutionary right there.
Amazing. And give us some more insight into applications. What are the applications of the Mach reactor technology?
So we're using the Mach reactor technology primarily at the moment for flotation enhancement. So the PGM plant in particular is sort of, if I look at where my business lies, a lot of it's in the PGM industry in flotation. And the key there is these pico bubbles are also very good at picking up extremely fine, valuable mineral that is lost in conventional flotation plants. So now the PGM industry has been milling finer and finer, and they've put in these fancy bead milling, etc. up front, and they're going, some of them mill down to 10 microns or 20 microns. But the question they've got to ask themselves, can you actually float a 10 or 20 micron size particle? It's fully liberated at that size. But does conventional flotation technology allow you to pick that up, and have that in your concentrate? And the answer is, it doesn't. Conventional technology does not do a very good job. And I think 60 to 70%, if you look at the losses in PGM plants' tails, 60 to 70% is actually in the fines. And so it provides an opportunity for the Mach to give you that enhancement. So we come in with preconditioning ahead of any float plant. We generate these pico bubbles directly on these fine particle surfaces, because that's how cavitation works. It wants to nucleate on a hydrophobic particle, which is your target mineral. So we directly generate these pico bubbles on these fine particles, get them to aggregate, which happens naturally as they move to a lower energy state, and we pull them up into the concentrate. So that is a pretty unique application that we have in flotation. So it would apply not only to PGMs, but to base metals, copper, industrial minerals, etc. That's the flotation side. And then on the leaching side, and I put purposefully talking about leaching second, because, having oxygen injectors in the leaching industry, in the gold industries, that's been going on for decades now. But as I said, with this pico bubble generation with the Mach, we do bring a very special, twist to it. And we have something extra and special to bring to the party in terms of those efficiencies that we grant. So we have extremely fast leaching kinetics with the Mach, which allows you to reduce the size of a gold plant. So, for example, in South Africa, where the treatment of tailings has become so popular, you need to treat very high volumes, high tonnages of these tailings for it to be profitable. And the Mach would then allow you to build a very small plant, a plant with just a couple of hours of residence time, which brings your capital cost right down, and your recoveries are still going to be there, if not even better. So, there's the kinetic advantage. And of course, what everybody wants to see is improved recovery. You want to see that improvement on your bottom line. And then again, for leaching, it's not restricted to gold. People are now using it for base metal leaching as well, because the fundamentals are the same. So the Mach really addresses the fundamentals of mass transfer, which is everywhere in metallurgy, in all extraction processes. So I suppose your mind is the only limitation when it comes to applications of the Mach.
But then on that value proposition, how quick is payback of the Mach?
Yeah, payback is, you can have a problem, Martin, where something is just too good to be true, and when I usually go talking to clients, and we chat about it, and we finally get down to the economics and the finances, because it's usually the last thing you talk about, because it's like a swear word, money. In polite company, you don't talk about money. But at the end of the day, the payback is very, very fast with the Mach, because the capital cost to install a Mach, if you compare it to the cost of building it, it's a couple of pumps and pipes. It's pipes, pipeline, and maybe one big pump. So it's not a lot of capital to give you these huge gains. And the gains I'm talking about is between 2 and 8% in recovery, for example. If I'm looking at some of my gold clients that treat semi-refractory, difficult to extract material, and even the PGM clients. So when you start looking at that type of recovery improvement, and the money that you need to spend to achieve it, it's paid back in a lot of instances within a couple of months. I would say, if I had to tell you it's paid back within a 6-month period, I'm being very conservative. Some of those clients of mine paid off in 2 to 3 months, and I stopped getting information. So that's how I know when it works, because I commission the MACH, and we'll talk about any problems they may experience, and they start sharing information, and then suddenly there's no more sharing, and all I hear is, we're happy with it, it works. And that tells me, okay, 3 months, you've probably paid it off already, because you can do the math yourself,
So then what reasoning do potential clients put forward for not doing business with GoldOre?
Now, that's always a tough one. And, GoldOre is we have a global footprint. So we're a South African company, proudly South African company, but our business is global. So we do business everywhere: Mexico, Kazakhstan, Turkey. And in fact, I'm very sad to say that 90% of the business that we do is outside of South Africa, believe it or not. And you would think, homegrown technology that is taking the world by storm would be embraced by South African mining houses, that, they should be trying to lever the maximum out of that. But yet we seem to be quite happy to let this homegrown technology roam overseas and help everybody else. And what I'm finding is, it's that really conventional or conservative thinking that we have, especially in South Africa. And I'm not going to get into the nepotism and the corruption and all of that. That's obviously there. Because when I speak science and business to people who are serious about those topics, usually we get traction, and we move forward, and we end up doing an installation, and my clients make money out of it. So when somebody does not want to listen to you, or doesn't want to take you seriously, etc., there's normally other underlying reasons, and I get more excuses than reasons. So people will say, how big is your company, GoldOre? It's a small company. We have a very small core team, and we outsource a lot of what we do. But then again, if you have technology that does not break, that lasts more than 10 years, that needs no attention, why would you want to have a gigantic company with huge overheads? It just doesn't make any sense. So, but unfortunately, the industry is used to that, because all the other competitors in the market have units that do break and that do need maintenance. So they need all these people always visiting the site, checking if it's working, etc. And so that sort of became the norm. That's what people are used to. The magic here is the MACH. So you've got to look at what is the really important thing. What is the lever that you're looking for? And if it is technology.
And the green agenda is big these days. How do you, as GoldOre, address this green agenda?
The green agenda and the MACH, sort of the elephant in the room is power. So I've been talking about the MACH reactor, and I mentioned a pump, etc. And obviously that pump has a motor on it. So we do require power to run the MACH reactor. So the MACH reactor has no moving parts. It's a Venturi-based system, and you have to physically pump the slurry of the pulp through the reactor, which takes energy. And that's why I say that's the elephant in the room, right? Because the green agenda, people want to reduce energy. And but we've contributed to that. So we've done a lot of R&D. We actually started before it became such a hot topic, the whole ESG thing. We started a while back doing research, trying to see how we can optimize the internals, the Venturis of the MACH, etc., to reduce power. And I'm very proud to announce, or to tell you, that we have managed to reduce the power by as much as 70%. 70%, that's huge. That's huge. And that was because the original design that we did, we wanted, when you introduce new technology, you got to make sure it works. It's got to work, it's got to deliver, and it's got to not break. Because if the first one you put out there does not work, it is so difficult to recover from that and to gain the trust of the industry again. So having said that, we really over-designed the original reactors. We had a lot of safety nets in there. If this failed, then we have that as a backup. We had so many backups, and all of those backups cost energy. But now that we've discovered that, look, it doesn't wear out, it doesn't break, it doesn't block. So we're able to actually streamline that design, and that's how we got the energy consumption down. So if that was a reason for people not to do business with, sorry, you don't have that reason anymore, because it doesn't actually consume that much power. And of course now, I'm talking about efficiencies, but when it comes to reducing the carbon footprint, efficiencies, it is important. And I know that retreatment of tailings is a business for a lot of companies. A lot of companies use that as they just do surface treatment. And I suppose that's fine because they're cleaning up the environment. But wouldn't it be much better to just have your plant efficiencies that high at such a level that it wouldn't even be economical for you to go and retreat tailings? That would be the ultimate. So you mine, you spend all that money on mining, you process it really well, really efficiently. And when you dispose of tailings, you do a final safe deposition of tailings that's friendly to the environment. That should be the ultimate goal. And the Mach reactor is that tool, that is there. It's available to the industry, and that allows them to chase that goal. That should actually be, I suppose, taken a lot more seriously by people. And then the last one is the zero maintenance thing. I mean, you only build a Mach reactor once. It can last over 10 years. You don't have to fly spares around all over the world. You don't have to fly staff. You don't have to power up cranes with diesel, etc., to do maintenance. So if you look at it from that perspective in the long run over the years, that also contributes to quite a large extent in reducing carbon footprint.
How does GoldOre ensure that it stays relevant?
Apart from the tried and tested applications of flotation enhancement and leach enhancement for PGM and gold plants, one has to bear in mind that the Mach reactor addresses the very fundamentals of mass transfer. So it can find application in quite a few fields apart from the tried and tested ones. And whereas GoldOre does not we don't really follow fashion trends in the mining industry. We have something that has proved very unique, which we're very proud of. And we will use that reactor in applications where we see that we get the best benefit. But recently, of course, with the whole emergence of battery minerals as almost a new sector of mining, even though they're base metals, right? They're copper and other things as well thrown in there, but they're termed battery minerals, and that's what we're going to need going forward towards our quest for carbon net zero. And GoldOre's invested actually quite a bit of money and time doing research on copper flotation, for example, and we were pleasantly surprised to find that the response was very, very similar to what we see on PGM ore, and bearing in mind that a lot of the PGM ore has base metal, they're base metal sulfide, so they have some copper, nickel, etc. in there, which we've been collecting very successfully in the PGM, but more as a byproduct. And what we find with the copper ore is that we get a very similar response. We need fewer passes with the Mach, which means smaller reactors, and also GoldOre has this unique ability to build the largest reactors on the market. So whereas the largest one you can get from competition is probably 600 cube an hour, we build single reactors that can do up to 3,000 cube an hour. That's a whole other league. And you find copper concentrators also very high tonnage operations. They tend to put through a lot of volume. And so for this application of the Mach to be practical and economical, we would need to have a really large reactor, which we have. And we have people in the world that actually run these big units very successfully. And so I suppose we managed to keep ourselves in the limelight, in the focus of what the industry is looking at and what's important for the future. Hopefully we'll be part of that solution for battery minerals.
That was Creamer Media's Mining Weekly, speaking to Adrian Singh, the CEO of GoldOre.